Again, it can be argued that our senses and perceptions are highly effective and sufficiently so to enable us to move through the day walking, eating, working, playing, and basically interacting with the world in a predictable way. In some cases, our senses play tricks on us, and these illusions have been closely studied and provide a source of amusement. These cases represent a fraction of our sensory experience, and our ability to recognize illusions as illusions suggests there is a deeper element to our perception, which chimes with our internal model of the external world. What Feyerabend leads up to is the case of Copernicus, whose theory was in stark contradiction to the observable facts of the day, which would have obstructed the acceptance of his theory. However, this example of celebrity science is but a single retrospective example which may represent a confirmatory bias. In order to use induction to generate a rule, as Feyerabend seems to be doing in this case, I would prefer to see further data from different branches of science to support this rule. Again, if we turn to Darwin's theory of evolution, we can ask, does this theory contradict the sensory information that Darwin was furnished with prior to the construction of his theory? It is difficult, if not impossible, to know, as we are talking about a historical case. We no longer have access to Darwin's thought processes except through his writings, nor for that matter do we have access to the thought processes of Copernicus. However, Darwin once wrote the following, quote,
"I am turned into a sort of machine for observing facts and grinding out conclusions."
Another curious point here is that Feyerabend is arguing from the experience of Copernicus, the same experience that he maintains Hume argues cannot be used to generate theories. So, if experience cannot be used to generate theories, why is Feyerabend using this to generate rules? If there is a rule for science, then why should there not be this same rule for philosophy? In any case, Feyerabend goes on to assert that counterinduction is a fact and a, quote, much needed move in the game of science, unquote. In chapter 6, Feyerabend gives the example of Galileo, who says that he does not explicitly state each part of the chain in his reasoning. Although Feyerabend provides us with a fact to support his theory, this again could result from confirmatory bias. Similarly, using the same line of reasoning that Feyerabend proposes about facts and theory, why is it necessary for Feyerabend to support his rule with a fact? In any case, the cited examples do not exclude the possibility that Galileo had a detailed chain of reasoning. Indeed, another author has suggested that theories are constructed by an elaborate line of reasoning, which may occur out of conscious awareness. See the book Gödel, Escher and Bach. In this chapter, he describes natural interpretations which involve the combination of the sensations and the responses to those sensations. He says that this can be treated in one of two ways. In the first method, suggested by Bacon, the natural interpretations should be broken down into their constituent parts, much like the peeling of layers of an onion. In the second method, proposed by Kant, they have been regarded as a priori presuppositions of science. Feyerabend then argues that natural interpretation was used to confirm the Copernican theory of motion, and that Galileo's trick was to subtly introduce an alternative theory and to enable his audience to confirm this theory by means of natural interpretation. He also replaced natural interpretations which contradicted the Copernican theory with those that did not. He further develops this idea in chapter 7. In this chapter, Feyerabend states that Galileo has introduced a law of circular inertia and the idea of relativity of all motion. He asserts that
Galileo uses propaganda.
I found it difficult to follow Feyerabend's discussion for several reasons. 1. Feyerabend's discussion occurs in the form of an essay, whereas on close reading there are a number of assumptions which are being stated. These could have been presented differently so as to produce a more coherent structure. 2. I found myself dependent on Feyerabend for his interpretation of Galileo and Copernicus, which is relevant given points 3 and 4. 3. Feyerabend selectively quotes from Galileo's works. 4. there are difficulties in understanding Galileo's works. A. The works referenced by Feyerabend are translations of the original Italian. B. The language used by Galileo may be peculiar to that period of history, and therefore a contemporary reading may lead to misinterpretations of the original meaning. Feyerabend himself hints at this when he writes that
they speak the language of real motion in the context of 17th century everyday thought. At least, that is what Galileo tells us.
C. Galileo's writings must be interpreted in the proper historical context, as there would be expected to be profound cultural differences in comparison with contemporary culture. In this chapter, Feyerabend reiterates some of the points from the previous chapter, before moving on to the telescope. While at the beginning of the chapter, Feyerabend states that,
however, he offers no theoretical reasons why the telescope should be expected to give a true picture of the sky.
He goes on to suggest that Galileo had written about some calculations he had made to confirm the accuracy of the telescope, but Feyerabend is unable to identify these, and instead suggests that Galileo verified the telescope's accuracy through experience. He further supports this assertion by reference to a translated quote from Galileo, in which he writes that the accuracy has been verified with reference to 100,000 observations on stars and other objects. The essence of this chapter consists of an interpretation of a specific aspect of medieval European history in order to support the assertion that Galileo's reliance on the telescope, an extension of his senses, was based on experience and not on theory. However, it could be argued that relevant evidence of Galileo's calculations has not remained. Feyerabend also comments on the writing of Galileo about the nature of light, thus,
even if we consider such utterances with the care that is needed in the case of a whimsical author like Galileo.
And he further quotes Professor E. Hoppe thus,
Galileo's assertion that having heard of the Dutch telescope he reconstructed the apparatus by mathematical calculation must of course be understood with a grain of salt, for in his writings we do not find any calculations.
Feyerabend thus takes time to discredit Galileo both in his scientific endeavours and in his skills as an author, and yet it is from a translation of these same writings that Feyerabend bases the central argument in his work. This shows one of the drawbacks of a historical analysis when investigating the process by which science is performed. If instead a living scientist had been selected, then the scientist could have been interviewed directly in order to confirm or refute the above assertions, and the quality of evidence to support the arguments in the case of important scientific discoveries would be expected to be of a higher quality. The quality should be higher given the wide variety of media that are available for disseminating such discoveries, as well as the process behind them, the means for storing items from these media, and the larger population from which may be drawn a larger group of people focused on responding to and reporting on important developments in science. Here, Feyerabend continues the argument that there was little reason for Galileo to suppose that the telescope offered a true picture of the sky, and focuses on why Galileo's drawings of the moon bore no resemblance to the lunar landscape that is seen today.
Having been influenced by Wittgenstein, Hansen and others, I was for some time inclined towards the second version, but it now seems to me that it is ruled out both by physiology, psychology, and by historical information.